which means that I'm given some statement and I've got to solve. So I want to work out the values, say, of x, where sine of x is equal to root 3 over 2. So what I'm actually doing when I'm solving trig equations is I'm thinking about a graph. Say here's sine, and I want to know where this graph, what points on this graph are equal to a value. So if I want to know where sine is equal to a half, there's obviously lots of values and then more values here. I want to know what these values are. Notice in most questions I have some sort of domain. So here I'm solving between 0 and 360. If I'm not given a domain, then my values are endless. So I would have to generalize my solution. In these ones at the moment we're going to have a given domain. So there can be more than one solution to a trig equation if we look at a larger domain. Always pay attention to the domain in which the angle can lie. So let's have a look at this one. I'm going to show you my steps to solve these. So I want sine of something that's going to give me root 3 over 2. What I always start with is I always draw my exact triangles first of all, and I think about a related angle that gives me root 3 over 2. So here's 60, or you can take out your reference sheet and do this. I know that sine of 60 gives me root 3 over 2. Root 3 over 2. So I can say that my related angle equals 60 degrees. Now, I need to think about, is this a positive or a negative number? And I need to think about all the possible values that could give me this root 3 over 2 in this domain. So I first of all draw my all stations to central, and I think about how many times going from 0 all the way to 360 can I have a positive solution for sine. I can have it in the first quadrant and the second quadrant. So I'm going to say that my answer for x between 0 and 360 is going to be 60 in the first quadrant, but in the second quadrant, now there's some rules that we learned for this. Theta, 180 minus theta, 180 plus theta, 360 minus theta. In the second quadrant, my rule is 180 minus that angle. So it's 180 minus 60. So my answers are 60 and 120. Now, as a check, I can get my calculator out and I can check that when I type in sine of 60 that I get root 3 on 2, which is 0.866. Then I can check that sine of 120 gives me that as well, and it does. Okay? Now, second equations. Any questions on that?
Yeah.
Yes.
What was the Mr. Katie's way of remembering that thing?
I'm not going to say it on the video.
What do you mean, Miss?
Now, solve the equation. When I solve this, I'm actually going between minus 180 and 80. So when I solve this equation, I'm going to go this way in the negative direction, and I'm going to go this way in the positive direction. So I'll keep that in mind. Now, this is my equation. My answer is minus a half. But for the moment, I want to think about a value, looking back at my exact triangle, that's going to give me half. So I need opposite, and it's sine opposite over hypotenuse. So it's going to be 30. So my related angle for x is 30 degrees because sine 30 equals a half. Now, I want my answer to be a negative. And I've got sine, so I'm looking for the two quadrants where sine is negative. So it can't be this one, it can't be this one, has to be this one, has to be this one. Okay? Now, when I go from 0 to 180, I'm talking about positive angles, but when I go between 0 and minus 180, I'm talking about negative angles. So if I was to draw this graph, I'm only considering this and this. If I know how to draw sine, this is x, and this is y equals sine x. So I know that I'm actually going to have two solutions by understanding the graphical solution of this to this. So they're going to be here. If I don't want to draw the graph, I can think about it like this. For negative angles, it's minus the angle in this quadrant, then it's minus 180 minus the angle in that quadrant. So my solution for x is going to be minus 30 degrees. And then in the quadrant here, which is the third quadrant, it's going to be minus 180 minus 30. Okay? So my answers are minus 30 and minus 150. Now, I want to check it on my calculator, so I want to type in sine of minus 30, and I get minus a half, and then I want to type in sine of minus 150, and I'm going to get minus a half. So I know they're okay, yep.
How do you like 330?
Because my domain says that I'm only going between minus 180 and 180. So I'm only considering a snapshot of this graph. If I didn't give myself a domain, I've got endless possibilities, but they've said between here and here. I know if I went a little bit further, down here, I would have another version there and another version there. They're the ones you wanted to give me in the third positive and the fourth positive quadrant, but I didn't want those. I only wanted it between there and there. So sometimes a graph helps me to understand that better. Okay? Any questions on that? Now, the equations can just get harder, of course, to all sorts of extreme strangeness. But I suppose that's why I really like this topic, because it's a little bit of a problem-solving thing to do as well. Okay, let's have a look. Now, find all possible values for x, for which that equals 4. Now, before I solve this one, I need to rearrange it. So I'm going to say cosec squared x is equal to 4 over 3. Now, I need to take the square root of both sides. So I get cosec x equals square root plus or minus 4 over 3. So cosec x is equal to plus or minus 2 over root 3. Now, this is an inverse function, so I can write it as sine x is equal to flip, so plus or minus root 3 over 2. Then I can go back to my exact triangle, and I had 2, 1, root 3, 60, 30, and 90 there. Now I want sine with root 3 over 2, so it's going to be 60 again. So my related angle, x equals 60. Now, I'm going between here and here, and between here and here. So it's between minus 180 and 180 again. So if I was thinking about my sine curve here and here, I'm thinking about all the solutions that give me root 3 on 2, which is 0.86. So there's a solution there, a solution there, a solution there, a solution there. I've got this plus or minus, which means it doesn't matter whether it's a positive 0.8 or a negative 0.8. So I can see from my graph that in this domain between minus 180, which is here, and 180, which is here, I'm actually going to have 4 solutions. I just want to write them out. So I'm going to say x is equal to, in the first quadrant it's going to be 60. In the second quadrant it's 180 minus 60, which is 120. Now, I stop there because I've reached 180. I go back this way. Here, it's minus 60. And in this quadrant here, it's going to be minus, and I'll write it out, that. So my final answer is minus 60, and then 180, so it's minus 120. So it's symmetrical, this sine curve. So 60, 120, minus 60, minus 120, okay? But be careful when you solve this kind of equation that you get the plus or minus, because that's a tricky point that people often make that mistake, and then they drop 2 of the solutions when they should have had all of them. Okay, now this is the last one I'm going to do of this, and then I'll do some more tomorrow. Now, in this case, I've got a double angle here. I've got 2x, so this makes it even trickier. So what I'm going to do is I'm going to say let u equals 2x. So my equation that I'm going to solve is this. I'm actually going to solve tan u equals root 3. Because I've got something that's happening here that I need to work out what x is, but there's a multiplying factor on that there. So I've got to multiply by 2 inside my tan. Now, my domain is set for x. So when I change my value from x to u, I have doubled my value here. So I'm going to change this to 720. Okay? Now, did everyone pay attention when I did that?
No.
When I change my pronumeral from x to u, u is 2 times x.
Yeah.
So instead of going around once to 360 degrees, I'm going to go around twice to 720 when I'm dealing with u. Now, this list here tells you the steps to take to solve these compound angle problems, okay? And I'll do another one tomorrow that's a little bit harder, but I'm just going to solve it the same way. So I'm going to go around twice. Now, I've got root 3. So when I've got this, I've got tan, so toe up. So it's going to be my related angle, u equals 60. I think I've used 60 a lot in these questions. I've got root 3 over 1 is toe up. Okay, and it's useful to have this triangle there. Now, my solution is positive root 3. So I want to know where tan is positive, there and there. But I go around again and I use that again and again. So I'm actually in the first quadrant, third quadrant, first again, third again. So u is equal to 60 first time around. Then it's equal to 180 plus 60. Then it's going to be equal to 360 plus 60. Then it's going to be equal to 360 plus 180 plus 60. Now, you don't need to show that much working. I just have to give you the idea there of what I'm doing. So this is going to be 240. And this is going to be what? 420. Now, what's this going to be? Plus 180.
Stop right there. I think that's sufficient.
So 600. Now, my solution is for you. I want you to solve for x. So the last step, solve for x. Therefore, x, now x is half. So my values are actually 30, 120, 210, 300. Now, don't forget, if you're nervous that you haven't got it right, put them in your calculator. Type in tan of 2 times 30, because it's 2 times x, and press equals. And I should get root 3, which is 1.7 I did. And you can check for all of those, okay? Now, that's all I'm going to do for now. Start 4G, and I'll also give